All right, here we go. Let's start by looking over section 2.1a, the 9 through, and I said 47. I should have made it 49. I screwed that up because I don't know my every other odds, I guess, very well. So, 9 through 49, every other odds, but whatever. So, number 9, what's the sign of 0, Dale? 0. What's the sign of pi over 6, Mason? 1/2. What's the cosine of pi over 2, Eli? 0. What, okay, what's the new coordinate after you move it pi over 4 to the right for number 21? Let's go to Andrew.
3 pi over 4, 3.
3 pi over 4, 3. Number 25, what'd you get for that one, Cameron? 5 pi over 4, 0. And now we're going to move everything pi over 3 to the left. So number 29, Eli Oaks.
0, 0.
No, 0, 1. No, not even 0. No, you did 27.
Oh.
The rest of us did 29.
Oh.
Okay. So 29, Parker Johnson, what do you have? 2 pi over 3, 1. Okay. 33, Eli Oaks, what did you get for that one? Negative 4 pi over 3, 1 is correct for 33. Okay, 37. What did you get, Mason?
4 pi over 6, 2.
Okay, here we get 4. Wait. So 4 pi over 6 is 2 pi over 3. So 2 pi over 3, 2 for 37. 2 pi over 3, 2. Okay, 41, Eli Barger. 13 pi over 6, negative 2. 13 pi over 6, negative 2, because you had to go pi over 6 to the right and 2 up.
Wait, what number is that?
41.
You got what?
13 pi over 6, negative 2. Because 2 pi is 12 pi over 6, plus 1 pi over 6 is 13 pi over 6. And then negative 4 plus 2 is negative 2. Okay, 45. What is halfway in between 0, 2 and pi over 4, 2, Eli Oaks? Pi over 8, 2. And then I bet we didn't do 49, did we? No. Okay, that's fine. All right. Then on to number, boom, boom, 63. Okay. If you're going to graph negative sine of x, what should you graph first? Y equals sine of x. Where does sine of x start? 0, 0. So we start at 0, 0. Pi over 2, sine of x is at 1. Pi, 0. 3 pi over 2, negative 1. 2 pi, 0. So it's a nice sinusoidal curve that looks like that. Okay, negative sine of x just tells me whatever I have graphed, my y is the opposite sign. Y equals the opposite of sine of x is what it's saying. So the y is opposite sign. Well, what's the opposite of 0? 0. What's the opposite of positive 1? Negative 1. 0, 1, negative 1. Now we have a strand of DNA going on there. Yeah. Okay. Number 65. Y equals negative 3 sine of x. Okay? Negative 3 sine of x. So we're going to graph again y equals sine of x. So y equals sine of x is what I'm first going to graph. 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0. Okay, so I need to multiply each of my y values by a -3. Well, what's 0 times -3? 0. What's 1 times -3? -3, so -1, -2, -3 is way down here. 0 times -3 is 0. -1 times -3 is 3. 1, 2, 3. Then back to 0. So now it looks like some DNA that's had some issues. All right, 67. 67 is y equals 1/2 cosine of x. So what should I graph first? Y equals cosine of x. Where does cosine of x start? 0, 1. The cosine of 0 radians is 1. The cosine of pi over 2 radians is 0. The cosine at pi is -1. 3 pi over 2 is 0. 2 pi is 1. Okay, so if we're going 1/2 of that, we go a y value half as tall. Half a tall is 1 is 1/2. Half a tall is 0 is 0. Half a tall -1/2 is -1/2. Whoops. Let's try this again. There. Suppose you're going to blame this on band. All right. Well, I'm recording, so whatever you missed is still on video and will get posted. All right. 69. 69 is y equals sine of x plus pi. Okay, what should we graph first? Y equals sine of x. So the sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is -1, sine of 2 pi is 0. So plus pi, if it is in parentheses, you have to think the opposite. So instead of going to the right pi, you should go to the left by pi. Oh, pi to the left is 12 spaces to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces to the left. 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 Okay, last one, 71. Y equals the cosine of x minus pi over 3. So again, y equals cosine of x. Where does cosine of x start? 0, 1. That's pi over 2, 0. Pi -1. 3 pi over 2, 0. 2 pi, 1. Okay? Minus pi over 3 moves us which direction? Left or right? Right by pi over 3. But how far is pi over 3? Well, in my graph, pi is 12 spaces. What's 1/3 of 12? 4. That's why I use 12 spaces, so I get an even number when I go. Because if I would just go 4 spaces, then it'd be in the middle somewhere, and then I'd be, I don't know. So I move everything 4 spaces to the right. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Bada bing, bada boom, we're done. Okay? Okay. So, let's move on. Now today, we're not moving on to new stuff. We're just taking and adding on to what we already know. So y equals ax, a all right, now I just had a brain fart. So let's start this all over again, Mr. Bierschbach. Okay. So y equals a sine of b times x minus c plus d. There we go. A stands for amplitude. Okay, that's a stretch and shrink up and down. B is period. We're not going to work with period until next week. We'll do period next week. C, phase shift left or right. Okay, minus C goes left, negative C goes left, positive C, whoa, negative C, yeah, minus C goes right, plus C goes left. And then D, it's the up and down, so plus D goes up, negative D goes down. Okay? So, we're going to take a function such as y equals 2 sine of x minus pi over 2 minus 1. And we're going to graph it all. Okay? So, go back to my colors. So, pi over 2, I'm making 12 spaces again. Now, when we start doing periods, you'll have to kind of watch out, because if we're going to stretch some things way out, we can't make it 12 spaces or it'll never fit on the paper. All right, so what's the very base function of this? What's the very base function of this problem? Sine of x. So y equals sine of x. So what we're going to do is we're going to graph out y equals sine of x first, which is 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0. Okay, then I always work left to right. So then I'm going to hit amplitude next. So the next thing I'm going to graph is y equals 2 sine of x. What does 2 sine of x do to the first point at 0, 0? What does 2 sine of x do to that first point at 0, 0? Not cotton picking things. Parker's over there shaking his head. Nothing. It's still there. 2 times 0 is still 0. So then what happens at pi over 2? Where do I go? Up to 2. Because you multiply 1 times 2 and you get 2. At pi, where are you going to be at? 0. At 3 pi over 2, where are you going to be at? Negative 2. And at 2 pi, where are you going to be at? 0. And there's a nice sine of 2x curve. Then I'm going to work with my sliding it. Let's go with purple. Y equals 2 sine of x minus pi over 2. X minus pi over 2. What does minus pi over 2 do it, Bailey? Minus pi over 2. Move it left, right, up, down, what? Moves it to the right, how far? Huh? 2? How many squares on my graph is pi over 2? How far did I go from here to here? How many squares is that? There's 6 squares there. Uno, dos, tres, cuatro, cinco, seis. So I go 6 squares. Okay. You see the 6 squares now. You didn't see it before, but now you do. Okay. So I'm going to go 6 squares to the right. Which graph am I going to take 6 squares to the right? My red or my green? Red. It's whatever the last graph you dealt with. So, red graph, 6 squares to the right. 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 There we go. Now, I'm to orange. This is my last step. What does the minus 1 in the back do? Down 1. 1 is 2 squares on my graph, so everything goes down by 1. I've just translated my graph. Okay, so 4 colors. Imagine that. Okay, we'll do one more, and then I'll let you get going on your homework already. Okay, we good? Well, even if you're not, I guess we're going on. Y equals -2 cosine of x plus pi over 3 plus 1. Okay, now, reading this, we got a pi over 3 involved. Okay, a pi over 3 is 1/3 of pi. So whatever you make pi, it needs to be something that you can take 1/3 of on your graph paper. Okay, and then 1 plus pi over 3 moves it which direction? Left pi over 3. So you got to make sure you have a little space to the left of your origin for what is going on. Okay, and you're going to wind up moving it, shifting everything up by 1. So if you start your origin down just by 1, that's not a bad thing. Make it a little lower than it is high, but mine's about the same. So again, I'm going to say, well, since I have pi over 3, let's just make it 12 to get to pi. So 3 to get to pi over 4. Pi over 2 is 6. Pi is 12. 3 pi over 2. And 2 pi. 1, 2, 3. -1, -2. Okay. All right. What's our base function of this? Y equals cosine of x. Where does cosine of x start at, Ashlyn? When you're at, what's the cosine of 0? 1. The cosine of 0 is 1. So we start there. Pi over 2 is 0. Pi -1. 3 pi over 2 is 0. 2 pi 1. Next graph, let's go pink. There we go. Y equals -2 cosine of x. Yee. It's going to be hard to see for some of you guys, I guess. So what do we do? Where is our first point going to be at? 0 what? If it's -2 cosine of x. 0, -2. Where's our pi over 2 point going to be at? 0. Pi will be at 2. 3 pi over 2, 0. 2 pi, -2. All right. Does that show up? It shows up decent on the board. All right. Let's see what other wild color we got here. Let's go with this bright green color. All right. Y equals -2 cosine of x plus pi over 3. Plus pi over 3 moves the pink graph where? Left by 4, because pi is 12, so we go 1/3 of 12. So we go left 4 squares. 4 squares to the left, 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 4 squares to the left. 1, 2, 3, 4. And then from the green graph, where does my orange graph go? From my green graph, where does my orange graph go? Up 1. Up 1. Up 1. Up 1. Up 1. Up 1. That's the graph of -2 cosine of x plus 3 plus 1. Okay, the orange graph. That's what we're doing today. Okay? We good with that? All right, so let me go to my plan book and see what our assignment is. So Friday, 9/23, Trig, we have 73, 75, 77, and 79 through 82 all. So 1, 2, 3, 4, 5, 6, 7 problems to do. Okay, 7 problems to do for Monday.